According to a rule of thumb, every 5 seconds between a lightning flash and the following thunder gives the distance to the flash in miles, assuming that the flash of light arrives in essentially no time at all. Estimate the speed of sound in meters per second from this rule. Secondly, what would be the rule for kilometers? Okay, we are going firstly to solve the first part of the problem, which is estimation the speed of sound in meters per second from the given rule. Okay, just let's illustrate the rule which is given. The rule is stating that let's illustrate using this line. Let's assume that at this time t1, and let's equalize this time to 0 seconds. At this time t1 equals 0, the storm reaches. Okay, and according to this statement, the flash of light arrives in essentially no time at all. When the storm reaches, instantaneously the lightning is going to come. At this time, the light comes. Okay, and for every 5 seconds between lightning flash and the following, between a lightning flash and the following thunder gives the distance in 1 mile. This means that after 5 seconds, let's say that the other time t2 is equal to 5 seconds, the thunder is going to come. Okay, and the thunder in these 5 seconds is going to pass the distance which equals to 1 mile. From these given parameters, we want to estimate the speed of sound in meter per second. Just recall, when the speed is given without a prefix like average or instantaneous, then we need to calculate the instantaneous speed. So the instantaneous speed, okay, the instantaneous speed, we know that the instantaneous speed is equal to the time derivative for the distance, okay, with respect to time, as the equation for the distance for the thunder, or the equation that the thunder is traveling with is not given. So we are going to estimate, and the estimation is valid in this problem. So it's approximately equals to the distance divided by the difference in time. In this problem, the distance is 1 mile divided by 5 seconds. This distance is 1 mile. Just look at what is wanted. We want the speed of sound. I'm sorry if I said the speed of light. Okay, we want to calculate the speed of sound. They want to calculate the speed of sound in meters per second, but it's given in miles. So we are going to we know that in 1 mile we have 160 meters. So we are going to multiply this mile by 1,610 meter per mile. So when we do the multiplication, the answer is going to be 322 meter per second. Okay, but look, the given parameter in this problem are given with one significant digit, so we want to write this with one significant digit. So the answer is 300 meter per second. And the first part of problem is done. So let's go to the other part. What would be the rule for kilometers? We want to find the same rule, the rule of thumb, but instead of miles, we want to write it using kilometers, and this is easily can be done from the speed. We know that the speed is 300 meters per 1 second. Okay, we want to convert this into kilometers. In order to convert the meters into kilometers, we are going to multiply it by 1/1000. Numerator we have in its unit is kilometer, and in the denominator it's meter. So the answer is going to be 0.3 kilometers per 1 second. Okay, so for every 1 second between a lightning flash and the following thunder gives a distance of 0.3 kilometers. To make our answer homogeneous to the given problem, it's given by in the problem the distance is 1 mile, so we want to make the distance by 1 kilometer. So let's divide the denominator and the numerator by 0.3, and the answer is going to be 1 kilometer divided by 1 divided by 0.3 is approximately 3 seconds. So the rule is 1 kilometer distance is going to be passed by the thunder for every 3 seconds. See you